In this section 3.3, our goal is going to be to switch up some rules that we already knew and prove that lines are parallel rather than using those lines to prove things about angles. And what I mean that we're going to switch up what we already knew that basically if I have these two corresponding angles that we'd call them in those two positions, as long as those lines were parallel, that would be proof that they're congruent. But now by using the converse of that theorem that we've seen from before, again, converse just means we're flipping our hypothesis and our conclusion. Earlier, we said that if we start with parallel lines, that's going to be proof that those angles are congruent if they're corresponding. Now we're going to say if I know that those angles are congruent first without showing that the lines are parallel, notice I don't have any markings there, that would be evidence that these lines are in fact parallel if I know they're congruent to start with. And if I use a similar pair as what we've seen from before, we know that works also with alternate interior angles. Again, alternate kind of crossing over this transversal and interior still staying within these two parallel lines. But now again, reversing our situation from before we set it in this order, if I know the lines are parallel, that's going to mean that those alternate interiors are congruent. Now I'm just using what we call the converse of that theorem to switch that statement and say if these angles I observe to be congruent, that means that that's proof that these lines would in fact be parallel. We're going to see that same kind of reasoning for all these rules. So notice on the next one, same side interior. This is the only situation in our last section that they're not congruent. These two angles, again, same side. We haven't crossed over this transversal interior because we were both within these two parallel lines crossed by that transversal. I know that in this situation that if they were parallel, that's proof that they're supplementary. But now by using the converse, if I'm able to find out that these two angles 3 and 6 are going to be supplementary, so again, the measures add up to 180, that's going to be proof that those lines are parallel if I didn't already know that from before. And last one that we had is, again, alternate exterior. So still alternate is crossing over our transversal. Exterior, now that we're outside those two parallel lines. Again, now that I'm just choosing the converse, I know that if these two angles are congruent, that will be proof that those two lines are parallel. So a lot of these rules that we're using in the same way, notice that the conclusions are all the same. We just want to prove that these lines are going to be parallel. We just have different options to do that depending on what angle pair we start with. So let's say if we start with angle 1 and angle 2 being congruent, it's a nice idea to mark that in your figure. 1 and 2 being congruent would mark those angles here. It looks like if those angles are congruent, these would be what we call corresponding angles if I use this line as a transversal and these are my two parallel lines. So again, if those lines are parallel, it would be A and B, and we're using that, again, in terms of my justification, we're using the converse, or we can just name it as a conditional, if I know that those corresponding angles, again, they're corresponding whether or not the lines are parallel, but I know that if they're congruent, that's going to be proof that I was dealing with parallel lines. So again, I just kind of write out my proof statements like this. That way we don't have to remember which one's the theorem and which one's the converse of the original theorem. We can just say what we actually mean. We found that those angles to be congruent, so if they are congruent, that's proof that, again, these two lines were parallel because they were joined by M being the transversal. If I was to look at the other parallel situations, so 6 and 7, good idea also, again, to mark those congruent if I know that these are congruent to start with as my given. If those are congruent, to check our answer, see what kind of lines that would prove, it looks like that would actually prove my other pair. So it looks like if L and M are parallel, that's because these are in the same corresponding position. But again, now B is acting as our transversal between the two. If B is our transversal going between those two and, again, corresponding position, it's like saying bottom left of our first intersection and bottom left of our second intersection. I know that if they start out being congruent, that is going to be proof from our converse that those lines would in fact be parallel. We can do that with different sort of examples. So again, if I was to start with like this gate, just by starting with the fact that 2 and 1, or I guess 1 and 2, doesn't really matter which order, if I know that they're congruent, that is proof, I believe, that R and S would be parallel. A little bit hard to see here, but R and S would be those two lines that, again, we're proving that are parallel. So I think, yes, we do have the evidence for it. Just kind of comes down to identifying this as an angle pair. If I'm outside of these two parallel lines, we're thinking exterior. If I'm on opposite sides of this transversal, we're thinking alternate. So if I combine that both together, if I know that alternate interior, sorry, not interior, we just said that that was exterior. If alternate exterior angles are congruent, again, I just kind of write this as a conditional. That is proof that our lines are parallel. Or we could also just remember that as the converse of that original theorem. So we know that they're parallel by using 1 and 2, but there would be another way to justify that R and S would be parallel. So in this justification, I kind of just wrote this as a short proof. So if I was checking the proof that I wrote for that, let's just take that in steps. we do want to start off with whatever was given as a statement. So we're still given the same thing we were on that previous question, that 1 and 2 were going to be congruent to each other. So again, always nice to mark that in our figure if we're trying to use that in our proof. But besides just using the fact that those alternate exterior angles are congruent, we could also bring in this other angle, looks like angle 3. We know that angle 3 and angle 2 would be vertical to each other, so that's going to be proof that those are congruent. Again, just kind of using that single intersection. I know that 3 and 2 are going to share that kind of connection. And now if I notice that these are still another angle pair I could describe with angle 1 and angle 3, that's what I took as the next step of my short little proof here. I just said that if 1 and 3 were congruent, we know they're already congruent because we marked them so. Again, we don't know that these lines are parallel yet, so if you guys are trying to say something like corresponding angles, we don't know that that's true because we're trying to show the lines are parallel. I can't use that in order to justify it. But I could use the first 2 steps in our mini proof here and said that if both of those angles are congruent to angle 2, angle 1 and angle 3 are congruent to each other because of that transitive property. Again, that's our property that uses our linking angle, in this case angle 2, to link both of those other 2 together. We've already, again, marked that in our figure that those all share the same congruency marking. So this is going to be wrapping up our proof. We have shown it. If you guys were thinking corresponding angles, now again, all we're doing is we're thinking of that in reverse. Before we used the fact that we had parallel lines to prove that those were going to be congruent angles, but again, now we prove that a different way. We prove that using the vertical and the transitive step. So now that we've shown they're congruent, whether or not those lines are parallel, that is going to be proof that the lines are parallel because again, since those are in that corresponding position, top left and top left of those 2 intersections, if those corresponding angles are the ones that we proved are congruent, that is proof that those 2 lines R and S would have to be parallel. So we can prove this in different ways too. I can also prove this by using some algebra steps. If we're trying to find the value of x that would make A parallel to B, as long as I can identify the angle pair that this is referring to with those 2 angles that I'm given expressions for, it looks like that is on the same side of my transversal. It's also inside my 2 parallel lines. So if I remember that the same side interior rule is that these are going to be supplementary rather than congruent, and again, it's also kind of obvious if I think about just the way the angles are shaped. If I have an obtuse angle and an acute angle, they're probably not going to be congruent anyway. I know that to find x, I would have to make an equation that I can find the sum and have that sum be 180. Because again, if that sum is 180, that means that I have same side interior angles that are supplementary, and that would be proof that those 2 lines would be parallel. So this is just going to take a few algebra steps. Just want to combine my like terms. I want to subtract 120 from both sides using my subtraction property. Divide both sides by 2. Again, we call that the division property if I was trying to prove this. But that is going to get our answer for x. Again, if I was to substitute that back in, that means that those 2 angles added together should give me 180. And since they're same side interior, 180 means they're supplementary. Supplementary means that would have to be parallel. Next kind of question works similar. Again, you guys can try a response on that before I get to it. But this case, these do look like corresponding angles. We might want to be thinking going to be a little bit different from our last situation. Also, again, just by using a tip that the figure looks like these are 2 acute angles, those are not going to be supplementary this time. If I was to solve that question, I know that if I was using corresponding angles in that corresponding position, it looks like these should be congruent rather than supplementary. So I just set those 2 expressions equal this time. So using the same kind of algebra steps, add 2 to both sides, divide both sides by 3. If W is 19, that means I would get 55 as an expression for both angles. And since those, again, corresponding angles are congruent, that would be a proof by using the converse that those lines would have to be parallel. So that just kind of gets as a reminder. This question is just like asking which kind of proof should I use in which situation, I guess, which reasoning. And again, the first thing that we saw was this alternate interior angles theorem. So we saw other examples like alternate exterior. But we used the original theorem. Again, the way that we originally structured that was the fact that we were given parallel lines as a starting point. That's when we used it in our last section to prove that the angles are congruent. But now again, to use the converse, like any other converse, is just going to flip that statement around. So now, as we've seen on our last few examples, we want to use the fact that we have congruent angles to start with, and that's going to be a proof that the lines are parallel, rather than, again, our original theorem stating that the other way around. So now we want to show lines are parallel. We start with the fact that we have congruent angles, which is kind of like what we have here. We actually start with a couple pairs. We start with angles being congruent, and we start with the lines being congruent. One thing this figure is also missing, notice we're trying to prove that line P is parallel to line R. I would add in a P just to show that that's what we refer to with that top line there. But if I'm to think of a strategy first, because I do have that proof written out, my strategy is going to be eventually to show if I can find a connection between, it looks like these 2 numbered angles, 2 and 3. If I'm able to show that these 2 would eventually be congruent, again, that's a way to prove that these 2 lines are parallel. I can't use the example that they're parallel first. Like, we don't know they're congruent. But yeah, if I can eventually show that, if I can match up 2 and 3, that's going to be my strategy, because I think that's going to be enough to show that those two lines would have to be parallel. And I'll say reason why here in a second. But yeah, first I just want to start off with a given. Notice here you're actually given two statements as a given. Since the first statement, or part of the first statement, is linking together 1 and 3, notice that I can't really just form a connection with those two angles at the very start. I'm going to have to form a connection with angle 2 first. So I'm going to save this part of the given for now. But if I at least start with the fact that these two lines are parallel, and again, notice it's also marked on my figure, that way, using these two parallel lines, I should be able to establish a connection between angle 1 and angle 2. Again, if I'm then able to link 2 and 3 together, that was our goal, to eventually find out a way to prove that P and R would have to be parallel. So if I do want to find that connection between 1 and 2, that should be, again, going back to your original, or I guess not original, just from our last section, our proofs that we talked about before. If I find that 1 is congruent to 2, again, since I know that we start with parallel lines, I can use the fact that those corresponding angles should be congruent. And again, you could call this the corresponding angles theorem, or I just used the conditional. If lines are parallel, then that means that those corresponding angles are going to be congruent. We do have to remember what the pair is called. I couldn't call that, for example, like alternate interior, alternate exterior. They are in the corresponding position, so I'd have to make sure I identify them correctly. But again, as long as I know that 1 is congruent to 2, now I can bring back in this given. So we didn't choose to use it on the first step, but I can use it now to say that if 1 and 3 are also congruent, which again we knew from the start of the question, I'm already able to see on my figure that we've established a connection between 2 and 3, and that connection, as we've used it in some other examples, is going to be through that transitive property. Again, we've used the previous two statements. We know that angle 2 and angle 3 are both congruent to that same angle. Again, you want to think of this as like your sort of linking property. So since we're using, since we're using angle 1 as a link between the two, we've shown on the figure already that 2 and 3 should be congruent. And again, now we're thinking of our converse. If we've already shown that these angles are congruent, and that should be a pair that we can recognize, that's going to be a pair that uses this transversal in these two parallel lines that we want to prove, P and R. So I think we do have enough to show this very last step. Let's get back to it. We do have enough to show this last step, which again, we don't want to say prove. We want to show the reason why we're proving those lines are parallel. And again, that reason why that pair that we call it is alternate exterior. These angles that we just showed for 2 and 3, those are outside of my two parallel lines. They're also on the opposite side of that transversal, so in that alternate exterior position. But again, notice how we used it in a certain order. In the first case, we used the fact that the first two lines are parallel to prove that the angles are congruent. But then since we're able to establish a connection using my transitive property, now that I've already shown that those angles are congruent, I can then say that P and R have to be parallel because, again, we're using the converse of the theorem that we used previously. So you could either call this alternate exterior angle converse, or as a conditional, I just kind of write it like this. If I know the alternate exterior angles are congruent, that's a proof that the lines are parallel. But again, that's where we're going here, is we're switching up our last statement in saying, since we've already shown a connection between 2 and 3, that does prove a connection between those two lines, P and R.